have test trial number 1. This is Noah and Dalton. Alright guys, tell us about your domino chain. What's going to happen here?
Well, we think it's going to go down fast. And the forces is we press it. When we push this domino, it will hit this domino, which will hit this domino, which will, and it's going to go all down here to this domino.
Okay, and you think it's going to be kind of a fast reaction?
Yes, ma'am.
And have you checked your distance yet?
44 inches.
Okay, how'd you figure out it was 44 inches?
When we measured it?
With a
Tape measure.
Okay, use tape measure. It's 44 inches. So you're going to see how fast. Who's got the timer?
I'll do.
Alright, Noah, are you ready?
1, 2, 3. 1 second, 50 milliseconds.
Alright, come write that down on your paper.
1 second. 1 second.
Second right, was that pretty fast? Did it go slower than you thought?
It went pretty fast. We thought it was going to wait like 2 seconds.
And what forces did you put on it?
Push.
Did push? Was there any pull?
Nope. No.
Isn't there always some kind of pull on
There's gravity.
on us? Yeah, there's always gravity. Why? This is take 2 of Hayden and Bailey's domino experiment with force and motion. Alright guys, tell us about this chain of dominoes that you have.
At the end, we have a new.
It is the
finales.
grand finale. And it is 39 inches. And I think it is going to go very fast.
Alright Bailey, what do you think?
I gotta go with Hayden.
Hmm?
I gotta go with Hayden.
Alright, so both of you think it's going to go fast. It's 39 inches. Alright, tell me about these dominoes you have at the end.
These are light dominoes and they're black.
Okay, so they're lighter than
They're gonna
the...
fall over a little bit easier than the other ones. It won't make as much noise.
Ah, so you think the other one's going to make more noise too.
And the one at the bottom is already down, so it will not fall.
And what kind of force are you going to use to knock over the dominoes?
Push.
So you're going to use a push,
And it is pulling them to the ground.
and gravity is going to pull them to the ground.
And
You have your
this
timer?
one right here,
Mm-hmm.
it's gonna show the gravity pulling it to the ground because that's gonna fall off and hit the ground.
Alright, so it's not going to be floating up here in the air when you knock it over. Alright, let's see. Okay, you have your timer ready? Ready, set, go.
1 second and 1.67 seconds.
Alright, write down your time.
And we are through.
Alright, good job. Test 2 of Will's domino experiment. Will, tell us what you did with this one.
I put the little black ones between each white one.
Alright, what's the difference in the black dominoes and the white dominoes?
The black ones are smaller and lighter.
So what do you think is going to happen? What's the difference in the motion of the heavy ones and the light ones?
The light ones wouldn't push down the bigger ones if you set them up. Keep tilting it like that.
Alright. So what kind of force are you going to use?
Push and pull.
Okay, what push force are you going to use?
Pushing it with my finger to knock it down.
And what pull force?
Gravity.
Okay, you got your timer. You ready? We got to hit the timer at the same time you hit those. 1, there you go. Oh, almost made it all the way to the end. There you go. What was your time?
7 seconds, 6 milliseconds.
Okay, write it down. Okay, how do you figure the speed?
The Divide the distance and the time.
Okay, go ahead and do that. See what your speed was.
$6 miles an hour. That's what the calculator says.
Okay. 6 per hour is what you were figuring up? Or are you doing it per second? So you're dividing by seconds, not hours, right? So it'd be per second. So did you think it was going to go that fast? You think it'd be slower?
Thought it'd be slower.
Thought it'd be slower than that? Why?
Because they were separated more and it would take longer for the push to knock it down.
Alright, anything else? That's it? Okay. Okay, this is Brandon, Shelby, and Stacy. Take 1. This is their first domino experiment. Okay, tell me about it. What kind of dominoes you use? The light ones, the heavy ones, or both?
Heavy. Heavy.
Use the heavy ones. What do you think is going to happen?
Fast. It's gonna go fast.
Okay, you think you're going to have a fast reaction. Which end are you going to start from?
The one that Stacy got
So
in.
you're going to start from over there, and it's going to come all the way down here. What kind of force are you going to use?
Push.
Push. What other force are you going to have on it?
Friction.
There will be a little bit of friction, and
Motion. Pull.
what kind of pull? What do we call that pull? Force that we always have?
Gravity.
Gravity. There you go. We're going to have some gravity on it. Ready with your stopwatch? Alright. Ready? 1, 2, 3.
Ta-da!
Alright, Shelby, what was the time?
2 seconds, then I don't know how
What's
to
the
say
other
2
two numbers?
seconds. 21.
Alright, so 2.21. Write that down, Stacy. 2.21. That's 2 seconds, 21 milliseconds. And what was your distance?
33 inches.
Okay, so you're going to find the velocity by dividing your distance divided by time. So go ahead and write down your distance was what?
33 inches.
33 divided by 2 point.
20. Here you go, Shelby. You're good at math.
No worries, I'm going to give you a calculator. Just go ahead and write down the equation. 33 divided by 2 point.
I don't know how to do this.
Let me do that. Let me do that.
Alright, while she's doing that, were you correct? Was that a fast reaction?
Yes.
Okay. What caused this last domino to fall down?
Dad.
You didn't touch the last one. You touched the first one. What happened?
The whole domino chain.
So it'd be kind
The
of...
last one hit the other one.
Okay, so you did have push, even though you only pushed one domino. We had push going on the whole time, didn't we? One push and then the other one.
And the push was really fast.
Mm-hmm.
Just like
Alright, very good. This is Kristen, Haley, and Morgan. Take 3, I believe.
4.
4 maybe? Okay. Take 4. They think they have it, so it will work this time. So tell us about it.
It is 54 inches long.
Okay.
And it's not heavy proof.
Did you use the heavy dominoes or the light ones?
Heavy.
Use the heavy one. So what kind of force are you going to use on this?
It has
Train
a
reaction.
push and push.
Okay, so you're going to push the first one, and that's the only one you have to touch.
Yeah.
And you should get a chain reaction of one pushing the other all the way across. Should. Any other forces? Gravity should be on the dominoes as they fall to the desk. Okay, what was the distance?
54 inches. We think.
54
Steve.
inches.
Okay. Have the timer ready?
Yes.
Alright. Ready, set, go. Okay, tell us what happened.
All of these fell down,
It
but
went
the first
kabuki.
time all of it fell down.
Mm-hmm.
When we didn't mean to do it.
So why do you think that your loop didn't work this time?
Because
one's faced that
this
way.
one's faced that way and it didn't go around.
Mm-hmm.
But it was faced that way the first time that went.
So it just wasn't quite close enough this
We
time
had
to get
this
it off.
straight and it was supposed to make a turn.
Alright, so you need to get the measuring tape and measure the straight line that it did fall.
That's 24 inches.
It was 24, so you remember that from before. Okay, so write that one down. That's going to be your new distance. Because that part actually did fall, so we can count that.
Let's write it again.
And write down your time. What was the...
4.16.
Okay, write that down. So what did you learn from this?
That it don't do it every single time we want it to. Even if you didn't mean to the first time, it does it anyway.
They knock down berries.
You learned that they do knock down easily.
You can't
Me
do.
too. That was a backward 6.
What else, guys? What'd you learn?
We learned that gravity holds it down.
And sometimes it don't work cooperate.
Okay. You have to make sure that one domino is going to hit the other one, right? If you had too much...
Have them too far apart.
Exactly.
Yeah,
Too much
force-
space,
yeah.
force just stops.
Yeah, force just
What
goes
if that would work? That would be awesome.
Yeah, I know. That's what I did.
Okay, this is Mylan and Jessica. Take 1 of the domino experiment. Alright, girls, tell me about your domino chain here.
We think it's gonna go fast since on a table it knocks over easily.
And it is 60 centimeters long.
Okay, so you measured it with the tape measure at 60 centimeters.
Yes.
Okay, where are you going to start the reaction?
Right here.
Going to start right there. And you think it's going to travel all the way around and come back to where you started from.
Yes.
Okay, what force are you using on it?
Push.
Okay, so you're just going to push the first domino. How's the last domino going to fall?
With the domino in front of it move.
Okay, so you push the first one, and then that one pushes the...
Next
Next
one
one.
and then the next one and then the
So
next
we're just going to keep on going. Y'all ready?
Yes.
Okay, got the timer ready?
Yes.
1, 2, 3. Okay, what was your time?
1 second.
Exactly 1 second? Or was it 1 point something?
1.77.
All right, write that down. So you've got 1 second, 77
Here's one.
milliseconds.
Okay.
Okay, so that was your speed, right? So we find velocity by doing distance divided by time. So we'll get you a calculator in a minute and let you figure that out. So what did you learn from this experiment?
I'm learning about push and pull.
Okay, so what kind of pull was on the dominoes? You talked about the push earlier. There is a pull on it. What was the pull?
Whenever you knock it down, it pulls the other one, or like the first one pulls.
Okay, the first one's actually going to push the next one all the way around. But there's a force that's always around us.
That the domino is going to fall.
Okay, they're going to fall because of what?
The push.
The push.
And why isn't it floating in the air? Why did it go down?
Gravity. The gravity.
That's what I was looking for. Gravity is that pulling force that's always on it. All right, anything else you want to tell us?
No.
That's it. This is Dylan. Take 1. Dylan, tell us about your domino chain here.
It's 30 centimeters long that way, 23 that way, and 30 that way.
Okay. Did you measure it in centimeters or inches?
Centimeters. No, inches.
I think you used the inches side. That'd be a little bit bigger than 30 centimeters. So you wrote down all of those. Okay, and then you'll be ready to add those together to get your total distance. Okay, what kind of force are you going to use on this domino chain?
Push
You're going to push one of them. Which side are you going to start on?
this one.
Okay, so what do you think is going to happen when you push that one?
It's gonna knock over those 2 rows, and then it's gonna knock down the straight one.
So you're going to knock down the straight one as it knocks down the other ones.
There we go.
All right, you ready? Okay, what was your time?
It was like 147, and then it went to 252.
Okay, so right now I think 147 was the first one. And then you hit it again. Let's go ahead and write that down.
83 inches.
Okay, so you had an 83 total, and you're going to figure out your speed in a little bit. Tell us about what happened. Did it do what you thought?
Yes.
Worked exactly like you thought it would. Anything else? Besides push, what other force did you have on it?
Pull and gravity.
You had pull, had gravity, so they're not floating around up here in the air. Alright, good job.
I said,